Moving on to the next question in the series of GATE 225 electrical engineering solutions from subject to power electronics. Next question is also 1 mark, numerical answer type, NAT. Question number 34 in the master question for GATE 225 electrical engineering from subject power electronics is from basically power MOSFET and power electronic power semiconductor switches. Question goes like question number 34. The master question for GATE 225 electrical engineering from subject power electronics. In the circuit with ideal devices, the power MOSFET is operated with a duty cycle of 0.4 in the switching cycle with I equal to 10 ampere and V equal to 15 volt. The power delivered by the current source in watt is dash, round off to the nearest integer. So we need to calculate the power delivered by the current source in watt, the nearest integer. Right. Round off to the nearest integer. Let's move to solution. Solution पे आगे बढ़ते हैं. सिंपल क्वेश्चन है, सब लिख सकते हैं. तो बेसिकली is my power MOSFET is given that power MOSFET is operated with duty cycle that is D equal to 0.4. So in a switching cycle, let the time period be T. So for dt time, that is 0 to dt, the 0.4 duty cycle, that is during this time the switch will be closed. Switch closed. So the effective circuit becomes like what? Switch closed means is an ideal power MOSFET, so it will be short. The gate voltage is given for this time period 0 to dt, short like this, and diode will be open like this. Right. Short means the voltage across the current source is what? 0. This voltage is 0. So the power delivered to the current source will be what? Power delivered, let's say energy, power delivered also, or energy equal to V into I. This V, not this V, but this is VI. So VI into I, that is 0 in this interval. Because it is short, across the current source there is no voltage, voltage नहीं है current source के across. तो इस ड्यूरेशन में ये हो गया 0. The switch closed है, power MOSFET, switch means power MOSFET here, power MOSFET on. Okay, ये तो एक टाइम हो गया 0 to dt. Now another, there will be another interval which will be dt to t, for which the power MOSFET will be off. 0.40 here, is 0.40. D is given as 0.4, so 0.4, 0 to 0.40, switch closed, power MOSFET on, so power delivered is 0. There is no voltage across the current source. And for dt, t between tt and t, that is 0.40 and t, power MOSFET is off. It is switch open. Switch open means what? The current source and the diode becomes short because the current is being conducted in this direction, so this effectively short circuits the diode. The effective circuit will be what? This. Like this. So VI will be what? Voltage across the current source will be same as V. It is 15 volt. Right. So the power delivered during this time will be what? Vi into I, that is V into I, that is 15 into 10. 15 into 10. That is 150 watts. But this will be occurring only for the time interval between dt, that is 0.40 and t. For the remaining time, the power delivered will be 0. So we need to find the average power, right? Average power. Power delivered unless otherwise mentioned, अगर कुछ नहीं दिया हुआ है तो एवरेज पावर ही मीन करता है. average power in this case will be what? Divided by the current source. Energy by time in a complete cycle, right? For this time interval 0.42 t, what is the time interval? Energy will be what? Power into time. So 150 into time interval is 0.42 t to t, that is t minus 0.4 t. The total time in a complete switching cycle is, switching period is t, into time is t, right? ये होगा, ठीक है? तो 150 into 0.6 t upon t. T cancels out, 150 into 0.6 gives 90. So the power delivered by the current source, average power delivered by the current source, that is Pi, we have calculated to be 90 watt. Because the answer is asking what power delivered by the current source in watt. The correct answer, nearest integer, it is already an integer, so it will be 90, right? As you can see clearly. So we solved it with the very basics of the power MOSFET, the switching device. When it is on, then it gets short circuit, so the voltage across the current source is 0 and there is no power delivered by the current source. When it is off, the switch is open, that gets short, and this is the resultant circuit. So the average the power delivered during that on switch open or power MOSFET off condition is 150 watt. The complete cycle, we then calculate the total energy and divide with the switching time period, which is t, and we got the average power delivered by the current source as 90 watt. The solution is clear and comprehensible. Very basic. I have tested on the very basics of the switching power semiconductor devices and power MOSFET. I hope the solution is clear and comprehensible. I have tried to explain each and every step, both the conditions to derive and obtain the final answer is 90 watt. So that's all for solutions question. Thank you.